Okay, this next section, what we're going to do in this next section is we're going to take a look at three-dimensional figures, and we're going to apply the Pythagorean theorem to these three-dimensional figures. So this very first problem here in the daily vitamin section you might want to take a look at, and maybe even pause and try this problem. Okay, if you've tried this problem now, if you take a look at this, what you have here is basically a three-dimensional rectangular box. And what you're looking for is you're trying to identify the three-dimensional diagonal and see if this golf club, sorry, I'm not the greatest at drawing here, if this golf club will actually fit in this box. And the box has dimensions of 9, of 20, and 25. And you need to basically find out what that three-dimensional diagonal is, and then see if a 33-inch golf club will fit. So the first thing you're going to do in this particular case is you're going to try to find the diagonal that is along the bottom of this box. So it's this two-dimensional diagonal right there. And what you're going to do is you're going to do Pythagorean theorem. So it's going to be 20 squared plus 25 squared is equal to x squared. And so x is going to be equal to, if I do the Pythagorean theorem here, 32.016, and then I probably should keep a bunch of decimal places after that because I'm in the middle of the problem. So that is going to be this length right there. And then next, I'm going to go and attack this triangle right there, the one that's kind of standing up diagonally through the center of the box. And in this particular case, again, I'm going to do, 32.016 and square it. Let's call this y. And then it's going to be 9 squared equals y squared. And then I can solve for y. Y will end up being equal to 33.26. So the question here is, does a 33-inch golf club fit in there? And it looks like it just barely fits into this box. Now, if I wanted to, I can go ahead and I can develop a formula for this, a general formula for this for any rectangular solid or any rectangular box. If the side lengths are A, B, and C, I can go ahead and try to find that formula. So again, if you want, you can pause right here and try to see if you can figure out the formula. If you don't want to try that, you can go ahead and just watch now as I go ahead and develop this formula. But I'm going to basically do it the same as I did in the previous problem. I'm going to go after the diagonal that's along the bottom here. Okay, so that diagonal there is going to be, let's call it x. It's going to be b squared plus c squared equals x squared. Or I know that that whole x will just be the square root of that, right? If I'm solving for x, I'm just going to square root both sides. And then, knowing that, I'm going to go ahead and take a look at this one again. Where the right angle is right there. And I know it's going to be a squared plus this x squared, or b squared plus c squared, the square root of that, squared, equals to, let's call it y squared, like that. And I know that what's going to happen here is the square root and the squaring is going to basically cancel each other out. I'm going to be left with a squared plus b squared plus c squared equals y squared. Take the square root of both sides, and there is my formula. Right, and if you think about this, you know, if I look at this formula, y squared equals a squared plus b squared plus c squared, it's basically the Pythagorean theorem with an added portion right there to kind of compensate for the extra dimension there. So let's try one problem. And so here's my problem. And I have 3 sides. And I'm basically just going to plug it into the formula. So it's going to be 4 root 2 squared plus 4 squared plus 2 root 10 squared. And really the only tricky thing here taking something like this and squaring it. Now keep in mind that this is just going to be 4 root 2 times 4 root 2. 4 and the 4, it's going to give you 16. Root 2 and the root 2, that's just going to be root 2 times root 2 is just 2. So the answer is going to be 32 there. Okay, and if I go ahead and finish this thing, it's going to end up being the square root of, I think, 88. Which simplifies to 2 times the square root of 22 if I were to ask you for an exact answer. Okay, so let's flip over to the other side now. Okay, here we are on the back side. We're moving on to a different type of three-dimensional figure. On the front side we did a rectangular solid or a rectangular box basically, and on the back side we're looking at a regular square pyramid. Okay, so basically here we have a figure that's going to be a regular figure, which is a square, and so all the sides of the base are going to be the same, which is the case in a square. And a pyramid, of course, is where all the corners here meet at a single vertex up on top. And that particular vertex is going to be right in the center of this height here. So in other words, it's not going to be shifted over this way or shifted over this way. It's going to be literally right over the center of this square that serves as our base for the pyramid. Now that dotted red line there is what we call an altitude. So that's what Py is. That is the altitude. Some other information here is a slant height is the altitude of one of the faces of the square pyramid. A lateral edge, so I think we're missing some letters here, sorry about that. Looks like this is going to be AM, it's just going to be D here, P-A-D-I-M, P-A-D-I-M, so the I belongs right there. Okay, and PD is going to be this guy right here, and that is going to be a lateral edge. So in the green right there, that's what's called a lateral edge. And so we're trying to find some of these various lengths here. And so let's go ahead and attack this. Find ID. So ID, given that the slant height is, let's label some things here. The slant height is 10. The base diagonal, so this is the base diagonal, the diagonal of the base. That thing is 12 root 2. Now, I know that this is a right angle right there, and I have a 45, 45, 90 right triangle, where this is, I can say this is x, this is also x, so I can do x squared plus x squared equals 12 root 2 squared, and solve for x. So this would be like 2x squared equals 12 root 2x, and if I solve this thing, I'm going to end up with x is equal to 12, and in the next section you'll see why I'm able to get that so quickly without actually doing any calculations really. Okay, so that ID is equal to 12. Py is the altitude. So if I know that ID is 12, then I know that this length right here, need another color, I know that this length right here is going to just be half of that, because if this is just the center of the square, this must be 6, and I can do from my triples that this must be a 6, 8, 10 right triangle, so that's where this kind of fits in this part of the chapter, so that altitude is going to be 8. And then to find PD, I'm going to take a look at, I can take a look at various triangles, but let's take a look at this triangle here, okay, on one of the faces. And you can see that this is a right angle right here. And I know that this side length is 12, so that means that this must be 6. And so the tricky part here is you might think that because this is a 6 and this is 10, that this must also be 8. But if you think about it, it really doesn't make sense that that is 8. And the reason why that's a little bit tricky is because that's my hypotenuse. 8 can't possibly be my hypotenuse. The longest side has to be the hypotenuse. So I'm going to have to do the Pythagorean theorem with this. 6 squared plus 10 squared equals x squared. And I'm going to solve for x here. I think x ends up being, through the magic of having this previously done, it's going to end up being 2 root 34. And that will be my lateral edge. Okay, and most of the problems in this section that have to do with pyramids will be just like this. The base will be a square, and you just need to figure out all the other information using the various right triangles that are available there and using the Pythagorean theorem. All right, I think I'm going to stop here and let you go ahead and try some of the rest of the problems on this worksheet. And good luck with that. All right.